Hello there and welcome back. This video is all about Asyncio and the new hot stuff in Python. This is described in one of the PyCon videos as cooperative multitasking, which means that if you write your script with enough sophistication, you could speed up basically the execution by utilizing the Asyncio module. And this tutorial is going to be all about that. So first, let us write a function which is going to be called async Fibonacci. Let's save it. And let's define the function Fibonacci n, and this is going to return either n if n is less than 2, as the Fibonacci n minus 1 plus Fibonacci n minus 2. So this is the recursive version. And I like it because it is pretty simple and elegant. And what we would like to test to see if how much performance gain we get from consecutive rounds. So let's say we call this Fibonacci, I don't know, around 5 or 10 times for different n values. What kind of performance we get without Asyncio and with Asyncio. So let's get to it. The easiest way is to write a function which is going to get the highest Fibonacci number below the specified number. So if I write the make the x equal to 1000, this should return back 987. I think that's the lowest Fibonacci below the 1000. So we will use f strings, and we say that the highest Fibonacci number below, and this is going to get the value of x. So the f string is also pretty cool and hot stuff in Python, because you could write this with either f string, or you could say that you want the substitution which goes with x, or you could also say that you want this way. And yeah, these are means to the same end, so you want to print something on the console. It's not that big of a deal, but if you can use, and you have an option with which comes with Python 3.6, you should try to use it as much as possible, because this is the direction where this is heading. So we will need for loop with the range, which was x range, and now it's renamed to range, but it's not relevant now. So if now we will calculate the Fibonacci y, and if the temp is greater than x, then we will calculate the Fibonacci again, but for the y minus 1. So if the current value of the return value of the Fibonacci is greater than the x, then the previous one should be less than the x. It's just a little bit of logic. And we will return the temp. But before that, we will print that the yes, Fibonacci number below x is dump. Seems about right. And we will have a function which is called get results, and all it is going to do is call the highest Fibonacci below with, I don't know, let's give it 10,000, 20,000, 30,000, and 60, 50, 40, and let's give it a bit higher numbers. And we will need the time function, so we should import it. And the t0 is time.time. Oh, let's be more elegant. So from time import time, and the t0 is going to be equal to time t1, sorry, and this all took me %.2f, which means that we want to print a floating point number with 2 digits after the point, so t1 minus t0, and the usual if name equals main. We will need to call the get results. Alright, let's take it for a test drive. Async Fibonacci. Oh, amateur. So it is now running, and is it good? Seems about right. Yeah. Well, it seems like there is something else missing, because we want to specify milliseconds. RG star, but it's about 21,000 milliseconds. And let's give it another run. So this should be kind of consistent, in a sense that this performance of the machine doesn't change, and the Fibonacci below functions are calculated sequentially, so as these come and go. Yeah, so around 21 seconds or 20,000 milliseconds. And what can we do to speed this up? So the first one we may want to start using is async def. So this will specify that this function definition is an async function, and what we will need to do is specify here also the async, and how is this? Command Shift away. Cool. We will need an event loop. So loop equals async ion.get event loop, and loop dot run until complete get results, and in the end loop dot close, and it's a double O. What is important, if you are using it from a Jupyter notebook, you should skip the loop.close because it will crash the notebook. But if we change it, now it means that we have partially used this async IO. But in order to use it, first we must import async IO. And for some reason it is still running in the specified order. So what we can do here is replace this await part and async wait. So this is going to call the async IO wait with an array of functions that need to be calculated. And if I run it now, it will throw me an error message which states that this was never awaited. Usually this error message means that you are missing an await keyword here before the async IO wait. And the problem here is that now we have partially provided this async functionality because the order of the functions have changed in which they are called, so it's kind of random. And this didn't really give any kind of speed bump here, but if we say that we want to ensure that there is a task switch between these functions, we should specify here the await async IO sleep 0.0.5. Let's save it. And now it should be really a fully fledged async IO function, because when it starts these functions, it runs for a while, and when this sleep kicks in, it hands off the execution to another function. And it goes like this, and in the end, you should see that only these three functions which have the highest number are going to be executed. So the smaller tasks are faster, and the higher numbers are calculated last. And it doesn't matter if I change the order of these, because this is not really relevant anymore. And let's see our task manager. So as you could see, it is utilizing the CPU a little bit more, and there is not much gain here regarding performance. But there are cases where it is definitely faster. And when you are writing these async IO routines, you should always make sure that you have a non-blocking version of the function you want to use or do. Because if you have this blocking version, it will totally wreck the basic idea of async IO. And this was all I wanted to show you. I would like to thank you for watching, and as always, the source code will be available on GitHub. See you in the next video.